the class.
Yeah, I also tried. First time I also tried. Then I second time I tried again.
Yeah, I told Soha just try again, try again. He said okay.
Okay, what I will do, I will shift it on Zoom. I think Zoom is better than Google Meet.
Yeah, I think. Let me.
Anything is easy so for you. That's good.
Yeah, I will check the Zoom as well. These are, software problem. Software problem of, because as I already told you that all video conference is UDP based. All video conference is UDP based. In UDP
Okay,
based, you will face this type of problem.
okay. You wanna send us the Zoom link?
I will try. No, no, not now. Brother, first I will check right by myself, and maybe tomorrow or after tomorrow we will change. Not today. Today, for today this is fine. Now we all are connected. Yes, Abdul. And what happened, Abdul?
I
Even
think so. Her trying to come to the class, but it can't. He can't. I don't know why.
what is the problem? This type of problem? No. Should I send link again?
Yeah, you can send him again.
Okay, wait. I'm doing one thing. I am sending the new meeting link. Yeah.
Yeah, he's here.
Hello, sir.
Hello, how are you?
Yeah, now it's fine.
Let me.
Now voice is echoing.
Yeah. Now everything is good. Yeah, we can hear you clearly.
Let me speak. Yes, from my side also. Yes, Abdul.
Yeah.
Great.
Yes, I can hear you as well. It's clear.
Great. So I was asking some question from OSI model.
Okay.
Like, but before starting OSI model, hope subnetting is very clear to everyone. Very clear. It
Yes.
means if I will assign any question of subnetting, you should be able to find the answer, and it's easy. And hope now you guys can do it.
Yeah, I think
Yeah,
we
we can do it.
understand.
If still anyone need help practice and more explanation, you can let me know. Then I will start OSI model. No problem. We don't have problem with time.
Okay.
So if any problem, like in subnetting, that I am not good in this part, like calculating valid host or finding the fifth network, last network, first network, this type of. So anything, if you are thinking that I am weak in any side, so you can let me know. Otherwise, I will move to OSI model, and next target is completely to focus on OSI model, so that we can understand the network fundamental as well. Once you will understand network fundamental, right, in a good way, either you can go for network security, go for cyber security, Linux, for any other technology, cloud. Every time this OSI model and network fundamental is required. Okay, before it you can survive nowhere. So we will try to understand network infrastructure very in very deep explanation. First, from the beginning explanation, like what is OSI model, why we come up with OSI model. By the way, we already discussed this. Why we come up with OSI model. Can anyone tell me why we come up with OSI model? What was the problem with OSI before OSI model?
Yeah, I think before OSI model, the data didn't transmit securely from one network to other network or from one host to other host.
No, no, no,
The
no, no,
OSI model, they just,
no, no, no.
no.
This is wrong. So from now, what I will do, I will tell you to write down some point. Okay,
Uh-huh.
and that point is very important point. Only important point I will tell you to note down. Okay,
Okay.
so note
Can you
down
share your
somewhere.
screen? Could you please share your screen and also don't forget the record.
Yeah, recording is on. Guys, whatever things here I am writing, please write in your notebook as well. Why we come up with. Okay, why we come up with OSI model to make communication possible between different vendor devices. Right? Means between vendor devices there was communication, but between vendor devices there was no communication. Getting my point?
Yes.
Like Dell computer was able to communicate with Dell computer. HP computers was able to communicate with only HP devices. Means HP printer can print out a print from HP laptop only. Getting my point? So
Yes.
that's why we come up with OSI model. Now what doesn't matter what your device is, even your device can be your printer, your device can be computer, router, switches, everything, every networking devices, right? So communication process or method of all devices will be same. Other thing will be different, right? Like a screen size, these are not a part of communication. Yes or no?
Yes.
Display color, these are not communication. For communication purpose we have some hardware as well as some software like NIC card. Yes or no? To connect, there are some software as well. So by using that, earlier all vendor was able to communicate with their own devices. But after OSI model tells us a common method to all vendor company to use that one. So process is not common. That's why all devices can communicate with. Now HP laptop can communicate with IBM laptop like that. After that, what is OSI model? What is OSI model? Yes, can anyone? Now question is what is OSI model?
It's operating system.
No. It is not an operating system. Even it is not a software or
Is it a
protocol.
computer layers or no?
It is a task.
7 layers of network.
Yes. That is task of each layer. Task is divided into 7 parts. But OSI model is what? It is a process which tells us how data will out from your computer and how data will enter in your computer. Write down this point as well. What is OSI model? Answer of this question is
Or
Hmm?
yeah, OSI model, how the data is into your
Your,
computer, how the
your
data
Yeah,
is.
screen is not shared.
Yeah,
how
I
data.
don't have your screen.
Here
Yes.
it is. What is OSI model? So OSI model tells us OSI model is a process. It is an, we can say,
Okay, it's a process.
process which tell us
The protocols, right?
it is a task that logically it is a task that every computer so whenever computer receive or transmit any data, that time computer perform this task. Logically it is an task that every computer perform to send and receive the data. Done. And this
Yes.
task is divided into how many part?
7.
7 part. And you already know why we divide anything. To make it easy, yes or no?
To make it easy for
Read for the people
more
who will,
secure and troubleshoot.
yes. So we divide this task into 7 part. Done. And can you tell me what is the name of first part? Let's say
Physical layer.
I'm talking about the sender perspective. So it will start from
Oh,
application,
sender is gonna be upside down. Yeah, okay.
Application layer.
application layer, then
Session
mm,
layer.
no,
Presentation layer.
yes,
Is it?
presentation.
Then session layer. Then transport layer. Then network layer. Then data link layer. And physical layer.
Very good. Then we have transport layer. Then we have network layer. Then we have data link layer and physical layer. Yes or no? So these three layers are upper layer, right? You already know application layer provide user interface. So here in bracket you can write down. Okay, let me write complete name over here. Data link layer and physical layer. Okay, yes or no?
Yes.
These are 7 layer according to sender machine. If I will talk about application layer, So application, what is the use of application layer in OSI model?
Which protocol you mean?
All
Application layer.
application and software belong to the application layer.
It provide user interface. A single line about this layer is what we can say. It's provide user interface. Interface, right? Like if you want to access the Google server, so here you have the interface. This is the interface. Through this only you can access google.com. Yes or no? Here I will
Yes.
type na www.google.com. Yes or no?
Yes.
So application layer is responsible to provide user interface every time. Like if you want to ping the Google, so you have CMD. This is what? This is also a interface. Yes or no, brother? This is an interface,
Yes.
yes or no? Because through this interface I can interact to somewhere. Got it? So
Yes.
this type of user interface we are getting from application layer. If I will talk about the presentation layer, so presentation layer is responsible to present the data, means it will perform encryption. Here you can write down. Provides user, it's provide what? Encryption, decryption, compression, and decompression. Done. After that, if I will talk about the session layer, so session layer do work. One work of session layer, tell me. It create, maintain and terminate the session. Create, the session. After that, from here your actual works is starting from the transport layer. So can anyone tell me what is the primary function of transport layer? We had already discussed this.
You said it's a port layer, right?
Definitely port layer. So it's provide guys, on this layer there are two protocol as well, TCP and UDP. TCP is transmission control protocol, UDP is user datagram protocol.
Okay.
Okay, by the way, the actual function of transport layer in one line, what we can say? We can say that it provides source, port and destination port to data. Done. If I will talk
Yes.
about the network layer, so what you can say, it provides.
IP address.
Yes, very good. Source, IP, and destination IP address to data. Getting my point? Getting my point, guys?
Yes.
Yes.
After that, data link layer. So data link layer is responsible to provide it.
MAC address
Very good.
or physical address
Provides source MAC
and destination.
and destination MAC. Okay. And after that, physical layer will,
Transporting bits.
Yes.
yes, transporting bits towards the destination. Yes or no?
Yes. Yes.
This is how OSI model works. Like, so these are, tasks. See, each layer is performing some task. Yes or no?
Yes.
Yes.
Adding source address, destination. These are tasks. So these tasks can be performed by manually by you, by network engineer, or we can run a automatic protocol for each task. And this is what we are doing. For each task, like at data link layer, there is one protocol who is waiting for the data. Whenever that protocol will receive any data from network layer, they will simply add source MAC, destination MAC, and that will hand over to physical layer, like that. On each layer, like network layer, protocol is waiting that when I will receive any data from transport layer, I will add source IP and destination IP to the destination to the data, and after that I will hand over to data link layer. Getting my point?
Yes.
So protocol is like your robot. Yes or no? Every layer. That is
Yes.
protocol. Okay. So we will
Yes.
discuss about that protocol also in detail. But this overview is clear to everyone.
Yes.
Yes.
Yes. Then please give me 1 minute. Let me continue it from here. Just give me 1 minute.
What is physical layer, Fuha?
Physical layer, it's just binary. It's just 0 1 binary layer.
Transport the bits.
Yeah, transport bits 0 1.
Thank you.
Okay. So if I will ask you guys one simple question here. Let's say I have only two computer. I am not adding anything. Let's say two computer are there. Computer 1 and let's say computer 2 over here. What happened here? Okay, and both are directly connected. Here, MAC address of this computer is, let's say, A. Let's suppose, and MAC address of this computer is, let's suppose, B. IP address of this computer is, let's suppose, 10.1.1.1, and IP address of this machine is, let's say, 10.1.1.2. Done.
Yes.
Okay, now on this computer, let's say on computer B, okay, let's say I want to check the connectivity from PC1 to PC2. So for connectivity, we have one utility, that is ping. Ping, P-I-N-G, right? Through ping, I can ping to the destination to check the connectivity. Is there IP connectivity between source and destination or not? For that only. And that protocol, for ping utility, the protocol which works is ICMP. And ICMP protocol works at layer 3. That means ICMP will generate traffic on layer 3. Yes or no?
Yes.
What I am saying, that there is one utility to check connectivity between two devices. Let's say I want to check the connectivity between PC1 to PC2. Is there connectivity or not? So I can use that utility, that is ping. Simply on PC number 1, you need to type ping, after that IP address of that device which you want to check connectivity. That's it. Also, we will type this command on PC number 1. Behind the scene, what will happen? After running this command, automatically one protocol will come in role. That protocol is responsible for ping, and that protocol is ICMP. ICMP. Internet Control Messaging Protocol. Okay. ICMP works for ping. Okay. So ICMP will generate one message at layer 3. Getting my point? At layer 3, ICMP protocol will generate a ICMP message. In that ICMP message, there will be some information like type code, like type and code value. Code that will specify it is an ICMP request or reply, because in ICMP there are two types of message for you now. There are two types of message. One is ICMP request message and another one is ICMP reply message. So if type code is 8, that means this type code is actually reserved for ICMP request. That means it is a request. So actually, after running this command, computer A generates one ICMP traffic at which layer? At layer 3, because this protocol works at layer 3. In that type field is 8 and code value will be 0. Code value will be 0, and you can check this information. Like on Google, you can type that ICMP type code. Type 3 code 3, like this you can check any number, type and code. Let's say important only. So important one is 0 that is reply, echo request, that means it is an 8, so this one is also important. ICMP redirect, you will understand it later. Destination unreachable 3, you will understand it later. And trace route 30, you will understand this one also later. And time extended, this one also you will learn later. For now, you need to understand two types of ICMP message. One is ICMP request message and another one is ICMP reply message. How you will identify request and reply? With the help of type code. If type code is 0, that means it is a reply. If type code is 8, that means it is a request. So in my scenario, I am pinging 10.1.1.2 from PC A, right? So my computer A is generating ICMP request message, right? So here let me start discussion from the initial. What will happen first? First of all, ICMP protocol will generate one packet, ICMP packet. In the ICMP packet, there will be type code, type, and type value will be 8, which I specify it is an ICMP request message. After that, at layer 3, this protocol is generated a traffic, but at the same layer it will hand over the traffic to IP protocol, to Internet Protocol version 4. See, there are some routing protocol and there are some routed protocol. Routing protocols is responsible to forward traffic on the basis of IP address, and routed protocol encapsulate the packet. Like this is my actual packet. If I will talk about the actual traffic, so this one is my actual traffic, right? This is your actual letter. So without addressing, you cannot forward this actual information to computer B. Yes or no? How this computer will came to know that where I need to forward this actual information? For that we have routed protocol, which will encapsulate the traffic so that traffic can reach to actual destination. And at layer 3, we have two routed protocol, let's say IPv4 and IPv6. So if my implementation is IPv4, that means here ICMP protocol is going to hand over it to IP version 4 protocol, right? And for ICMP version 6 also we have, that is for IPv6. If here IP implementation is IPv6, then ICMP will hand over it to IP protocol version 6. Here it is going to hand over it to IP protocol version 4, right? IP version protocol 4 will do what? It will add one simply network layer header. Network layer header. This one is nothing but network layer header, let's say. Let's say this one is network layer header. Done. In the header, network layer header, that is IP protocol have added this header. In that header, there will be information about source and destination IP address. First of all, source IP is 10.1.1.1. Destination IP is 10.1.1.2. After that, there will be some more information. First, there will be one field called protocol field. In protocol field, there will be information about the upper layer protocol, who have hand over the actual information to this IP protocol. See, transport layer can also hand over it to IP protocol traffic, and network layer protocol can also hand over traffic to IP protocol. But this time, who have hand over the actual traffic to IP protocol, ICMP protocol? Yes or no? So there will be protocol number of ICMP. Means upper layer, upper protocol than me is ICMP. Done. These will be the important information inside the inside the IP header. Inside the IP header. After that, here you are able to see actual information plus IP header. What we called it? We called it packet. We called it packet. Packet means your actual information. First of all, your actual information, and after that, IP header. Yes or no? This is IP header. Done. After that, IP protocol will simply hand over this packet to layer 2. To which layer? To layer number 2. Packet means you are very clear that actual information and plus IP header. Packet. To which layer? Data link layer. Layer 2. Now layer 2 will do what? At layer 2 actually, like IP protocol is responsible to encapsulate a packet at layer 3, like that at layer 2 ARPA protocol is responsible to encapsulate the frame at layer 2. At layer 2 we call traffic to frame. At layer 3 we call traffic to packet. Packet means actual information plus IP header. And at layer 2 ARPA protocol is going to do what? ARPA protocol is going to add one Ethernet header. In Ethernet header. In Ethernet header, there will be information about source MAC. That is what? Source MAC is 0A. After that, sorry, 0 not, only A. Destination MAC will be what? B. Destination MAC will be what? B. Yes or no?
Yes.
But question is how computer A will came to know about the destination MAC address?
So it will request app request, and it send
Yes.
its IP address and MAC address, and they have the request for their IP or MAC address.
Where this computer will try to find the destination MAC address?
So they do app request to find
Let's
destination
say
MAC.
let's say I have two computer like this.
Okay.
Here I am going to configure IP 10.1.1.1. And here I am going to configure IP 10.1.1.2. Done. IP configuration is done. See. This is PC 0. This is PC 1. Now if I will ping (10.1.1.2) from PC 0, that means I am pinging PC number 2. First of all, this computer is going to check their ARP table. Their ARP table. In the ARP table, are you able to see any entry?
No.
That means this computer don't know what is the MAC address of PC1. So if you will ping, first of all, it need to resolve what? Ping 10.1.1.2. See, I am able to ping, but now if you will check ARP table, so ARP, you can see there is one entry in ARP table that MAC address of 10.1.1.2 is this one. Yes or no?
Yes.
Yes.
So what happened behind the scene? Actually behind the scene, this actual information will goes on hold because destination MAC is unknown. So your actual information will goes on hold. Getting my point?
Yes.
And ARPA protocol need to encapsulate this frame now. So ARPA protocol will call one more protocol, that is ARP protocol. ARP protocol. ARP protocols work at layer 2. So it will generate a
MAC address.
ARP request. ARP request. Okay. Now again question is how to identify the request and reply. So for that we have opcode over here. Opcode. Opcode is similar like type field in ICMP. If opcode value is 0, that means it is an request. If opcode value is 1, that means it is an reply. Done. Inside the ARP message there will be some more information like sender MAC address, target MAC address. Target MAC address will be the MAC address of 10.1.1.2. Because this computer have information that destination IP address is this one because you have pinged that IP address, but this machine don't know the MAC address. After that it will again hand over ARP. Actually ARP protocol will again hand over it to ARPA protocol. ARPA protocol, and ARPA protocol will again encapsulate this ARP request to frame. It will add one Ethernet header over here. In Ethernet header, source MAC will be, this is Ethernet header. Source MAC will be what?
Computer
Source
B.
MAC will be 0. Sorry, A. Source MAC will be A.
A.
And destination MAC will be what?
B.
B. How this machine don't know the destination MAC. Computer A don't know the destination MAC, so how MAC address can be B? Destination MAC will be OLAF. OLAF means you know broadcast.
Yeah.
Done. And there will be one field called type field. In type field there will be information about the upper layer protocol. Means which protocols have handover actual information to me. That will be the information in type field. Done.
Yes.
After that, this machine will forward this ARP request to PC2. In the same way, PC2 will generate one reply. Yes or no?
Yes.
In the reply, they will share their own MAC address. After that, ARPA protocol will encapsulate the actual frame that is on hold. Here they will put destination MAC what?
B.
B. And there will be one type field. Yes or no?
Yes.
In type field, opcode will, do you think that opcode will be also there? No. Opcode is a part of ARP. Yes or no? Ethernet header is this one in different color. So I am talking about the Ethernet header. In Ethernet header, there will be source MAC, destination MAC, both is unicast. After that, there will be information about the type. So type will be the type code of IPv4. Here type code will be the type code of ARP protocol. Done?
Yes.
Okay. Okay. See. Done. After encapsulating this packet into frame, so what we call this value, this is your frame. So what is the meaning of your frame? Frame means your Ethernet header plus actual information, that is packet. Packet means actual information plus IP header. Now, when computer A will encapsulate frame, then it will hand over to physical layer, and physical layer will forward it to computer B. Yes or no?
Yes.
Computer B will do what? First of all, computer B will receive one frame at layer 2. Definitely, first of all, here physical layer will receive the frame. After that, it will hand over to data link layer. Now, data link layer have received these complete information at layer 2. Frame will be same. Yes or no?
Yes.
It is going to check simply first destination IP address. There will be one more information that is also important, that is TTL value. TTL will be, let's say, 255. We will discuss about the TTL value later. Okay. First of all, PC computer number 2 is going to check the destination IP address. If destination is my IP address, then only I will accept it. Otherwise, this computer will discard the frame. In two scenarios, actually, computer will accept it. One, if destination is if destination is broadcast. Only in two scenario. So if destination is broadcast, then also PC will check more information. If destination is their own IP address or MAC address, it is going to check more information. Done. So destination is B. Okay, B is the my MAC address. So this is for me. After that, it is going to check the type field. So in type field, there is information about IPv4. That means, okay, actual information is for IP version 4 protocol. So at layer 2, ARPA protocol will remove this extra information and it will hand over the packet to network layer. At network layer, to which protocol? See, layer are nothing. At layer, the protocols is running, that protocol is important. IP protocol is working now at layer 3. So it will hand over to IP protocol at
Layer 3.
Layer 3. IP protocol will open this packet in detail. So where is detailed information of this packet? Detailed information of this packet is here. This one is detailed information. Na? If you will open the packet, you will find these information. Yes or no?
Yes.
Here, router is going to check the destination IP address. Oh yes, destination IP address is also mine. Then I will check protocol field. In the protocol field, there is value of ICMP. That means actual information is of ICMP protocol. So computer B will remove this header at layer 3 and it will hand over the actual information to which protocol? To ICMP protocol. ICMP protocol will check type code. If type code is 8, that means someone has request me, so I will generate the reply. Getting my point?
Yes.
This is how in the same way computer B will generate reply. Let me show you here. One second guys, 1 minute. Okay. Do one thing. Here what I am going to do. Let me check the ARP table. PCs maintain ARP table for 4 hours. So there is one entry. What I am going to do here, I am going to remove the IP configuration. Let me check. See. What is happening on Ethernet link? Whenever you will configure the IP address, the IP address, first of all, link is going to check the duplicacy, that my IP address is duplicate or not. Getting my point?
Yes.
Once I will configure IP address here 10.1.1.1. First of all, this machine is going to send one. It is going to send one message to check duplicate IP address. That message is, see, here I am going to configure the IP address.
So what do you mean by duplicate IP address? We can apply only one IP to each host.
Yeah, when you will configure any IP address, see, are you able to see one packet over here?
Yes.
This packet is your Gracious ARP. One type of ARP packet it is, yes or no?
Yeah.
There are multiple types of ARP, we will discuss. But Gracious ARP is used to check duplicate IP address. Getting my point? Whenever we configure IP address on any Ethernet link, first of all, that link is going to, that port is going to check Gracious ARP. Generate Gracious ARP to check the duplicate IP address. In the Gracious ARP, if you will open it, see here.
Can you say again? Gracious?
Gracious. Yes, right. I am writing as well. Gracious. Gracious ARP. Getting my point?
Yes.
Whenever we configure IP address, you can write down somewhere. First of all machine is going to generate one Gracious ARP to check duplicate IP address. In the Gracious ARP, you can see the information. Opcode. Opcode is 1. Opcode is 1 means what? Okay, leave it also for now. See, target MAC address is 00000. Target IP address is 10.1.1.1. On the same IP address, it is sending the Gracious ARP. Who will generate reply? The machine who is using this IP address, yes or no?
Yes.
If this machine will get reply, that means this machine will give you error that this IP address is duplicate. If this machine will not get any error, then it will assign that IP address to their interface. Source IP address and destination IP address both are same. Yes or no?
Yes.
So actually when we configure IP address on the Ethernet port, first of all machine are going to generate one Gracious ARP to check duplicate IP address, and see it will forward to PC2 and PC2 will discard it because this is not the IP address of PC3. After that it will assign that IP address, and when I will configure IP address on PC number 3, PC number 3 will also generate one Gracious ARP. Yes or no? And if I will configure the same IP address over here, then PC1 will generate reply. But here I am going to configure the different IP address. See, the Gracious ARP. This time destination is broadcast. Here it is. Destination target is 10.2 and source is also 10.2. At layer 2, destination is broadcast. At layer 2, it is broadcast. But at layer 3, destination MAC address is OLAP, but destination IP address is 10.1.1.2.
So I have a question here.
Yes.
You said destination is a broadcast. If you have, for example, 10 other hosts or other PCs, they will
That will
receive
also
all
receive
10?
it. That will also receive every time that packet. That's why we have VLAN concept, na brother? To
Okay.
reduce the broadcast domain.
Mhm.
Yes or no?
Yes.
Okay, so it will also forward it to PC2, but PC2 will discard it. Now both machine have unique IP address. Yes or no? So I am going to ping 10.1.1.2. When I ping, see there are two traffic on PC number 2. One is ARP and one is ICMP. Very good. Why ARP is there? Why ICMP packet is on hold? See, ICMP traffic, Babu ka pakdo. ICMP traffic is on hold. First it is going to send what? ARP request. To find the MAC address of destination device. Yes or no?
Yes.
Oh, PC2 is saying that I know the IP address of PC3, that is 10.1.1.2, but I don't know the IP address.
The MAC address.
Please ARP find me, tell me what is the MAC address of 10.1.1.2, like that. Yes or no?
Yes.
If you will open the ARP packet in detail, if you want to see here. This is ARP request. This is still here. These are ARP request, and upper that on the top you can see Ethernet header. In the ARP, opcode value is again 1. It is a request. Source IP address 10.1.1.1. Target IP address 10.1.1.2. To whom MAC address I am looking for? 10.1.1.2. Done. Source MAC address is this one. So it is sending their source MAC address as well. So PC2 will automatically make one entry in their ARP table when PC2 will receive this message. Done. And in Ethernet header you can see destination is broadcast. Type code is 0x0806. This is actually type code of ARP protocol. This is a type code of ARP protocol. If I will talk about the type code of IPv4. So type code of IPv4 is 0x, what is that type code over here? 806 na, so here we have 800, this one. And ARP type code is 0x806. Done. Done, guys.
Yes.
Yes.
So here type code is this one. That means it is an ARP packet. Means who have actually hand over to Ethernet? So answer is ARP. By knowing that, by checking the type field only, Ethernet header can know to whom I need to hand over the information or data. Done. So PC will send first ARP request. In the ARP request, opcode is 1. And this one is nothing but the ARP reply. If you will open this ARP reply, so here in reply you can see source MAC is this one and target MAC is this one. Getting my point?
Yes.
Target IP address is this one. So to this I need to send this MAC address, my MAC address. And this time you can see ARP reply is unicast. Type code is same. Type code is same in Ethernet header because here also it have hand over by ARP protocol. Done. But opcode over here is what? Opcode 2. Opcode 2 means ARP reply, not 0. Done. Then this machine will send actual ICMP message because now in this machine you can check the ARP table. In the ARP table there is one entry. So it is sending the actual ICMP traffic. And if you will open actual ICMP traffic, so you can see some information here. In ICMP there will be layer 3 as well. Till here, till in ARP packet there are only 2 layers. Actual message and Ethernet header, but ICMP is an layer 3 protocol. So in the top you can see there is one ICMP protocol and type field is 8. 8 means it is an ICMP request message. Source IP, destination IP both are different. Source is the IP address of PC2 and destination is the IP address of PC3. TTL value is 128. We will understand TTL value later. These are the information inside the IP header. Okay. In ICMP there is only one hints that it is an ICMP request. Here in IP header there will be one protocol field. Yes, this one. In protocol field there is information about the ICMP protocol. Means IP protocol can came to know. Done. After that, Ethernet header. So this time two Ethernet header whom have hand over the actual traffic IPv4. So your type code you can see 0x800. This one. Getting my point, guys.
Yes.
After that it will generate ICMP reply. Again it will generate request. Again it will generate reply like this. Fourth time it will generate request. That's it. This is how two computers communicate with each other. And in ARP table, you can see the entry. MAC address of 10.2 is there. In computer 2, there will be entry for 10.1. There is no entry.
No.
So if you will ping 10.1.1.1, first this machine will generate what? ARP request. After that, you can see the entry. And this entry will be there for 4 hours. Okay, guys?
Yes.
This entry will be there for 4 hours.